All right, welcome everybody. Today we're going to talk about lesson number 46, and this is all about solving trig equations. Before we actually get into solving trig equations, I want to just point out really quickly on the side here, which you could jot down anywhere in the white space, the main difference between something that is not a trig equation and something that is a trig equation. So for example, if I was to ask you, what is the cosine of pi over 2? In order for you to solve that, you would look at your unit circle. You would look up at pi over 2. You would see the ordered pair 0, 1. And because a cosine is an x value, you would say that the cosine of pi over 2 would be 0. Compare that to if I was to say the cosine of x equals 0. In this second example, which is a trig equation, I'd be looking for all the values of x, not necessarily just pi over 2, that have a cosine of 0. So if you were to look at back to your unit circle, you would certainly see that not only does pi over 2 have a cosine of 0, but 3 pi over 2 as well. Well, what if I told you that you could go around the circle as many times as you want? What if I told you that you could only go around once or halfway or 3 times? So again, the biggest difference between a trig equation and a not trig equation is a trig equation has both a variable and an equal sign. So now that we've kind of got that going for us, consider the trig equation secant of theta equals 2 pi over 3. We're going to kind of come up with a plan for how we would solve an equation like that. We are basically looking for two values of theta, and we want them to be between 0 and 360. That means that we're going to be in degrees. So give your answer in degrees. The fact that it's 0 with no equal to and 360 with an equal to means that if there was an answer at that location, you would include the 360 but not include the 0 because it would be considered redundant. The fact that it says do this without a calculator, again, the AP test is part calculator, part no calculator. That is also how we would be doing our tests if this was a normal year. Right now, there's little that I can do to kind of force you to do that, but just in preparation for next year, without using a calculator, when you see those words, and if you were to see it next year, what that would imply is that you are on the unit circle. Remember, the AP test does not think that you have memorized the sine and cosine of every single value in the world, but it does assume that you will have memorized them for the unit circle. So again, here is our equation. The secant of theta equals 2 radical 3 over 3. And we're going to go ahead and try to solve that. So step one, whenever you're coming across a problem like this, is you're going to rewrite it in terms of sine, cosine, or tangent. Hopefully at this point, you remember that the secant is the reciprocal of the cosine. So I'm going to go ahead and rewrite this as the cosine of theta. And because it's the reciprocal, I'm going to flip my fraction. So 3 over 2 radical 3. Rationalize by multiplying by radical 3 over radical 3. That's going to give me 3 radical 3 over 6. And if I reduce the 3 and the 6, I'm going to get radical 3 over 2. So really, instead of solving the equation secant of theta equals 2 radical 3 over 3, I'm going to be solving the equation cosine of theta equals radical 3 over 2. The thought process behind that is that you're more likely to be familiar with sines and cosines as opposed to the reciprocals. Then here in the second box, make a note of the two possible quadrants where theta can terminate based on the sign of theta. So in this case, we have a cosine of theta that is positive. Hopefully you remember that cosines, if you're not on the unit circle, are equal to x over r. If you are on the unit circle, are just equal to x. Either way, the fact that you have positive x's, don't forget you're all students take calculus. At this point, you should know with very little work and honestly very little explanation that cosines are positive in either quadrant 1 and quadrant 4. So then take the inverse trig ratio of both sides to find an angle that satisfies. If you are doing this without a calculator, then it should be a unit circle value. So let's say that you go back to your cosine of theta equals the square root of 3 over 2. You're going to essentially take the inverse cosine of both sides. So the inverse cosine of the cosine of theta equals the inverse cosine of the square root of 3 over 2. An inverse cosine of a cosine is just theta. And then when you see the inverse cosine of radical 3 over 2, what that is saying is that on the unit circle, and the directions told you between 0 and 360, give all the places in degrees where there is a positive cosine of root 3 over 2. So if you look at your unit circle, which again, I'll assume at some point you're going to memorize, but for now, if you were to look at your unit circle and you were to look in quadrant 1, if you were to try to identify the degree measurement that would have a positive cosine of radical 3 over 2, that would certainly be 330 or 30. And then if you were to look in quadrant 4, that would be 330. So two different places on the unit circle where the cosine is equal to positive radical 3 over 2. Then in steps 4 and 5, draw the angle found in standard position, draw the first angle, and draw the second angle. So if you're talking about 30 degrees, then you're talking about starting in standard position, and you're going to show that it turns through an angle of 30 degrees. Then if you're talking about 330 degrees, then you would, of course, start also in standard position. You would turn all the way into the fourth quadrant, and you would be just 30 degrees shy. And again, that's because of reference angles. And I should be having my arrow there to show direction, and I should have my arrow here to show direction. And just like always, the answers that you get should always have the same reference angle. That's how and why this works. So that's kind of a longer way of doing the procedure. Obviously, the more that you do of these, the quicker they should be. So let's try to use the same plan to solve the equation sine of theta equals negative radical 3 over 2. So the fact that it's already a sine means that we do not have to rewrite it. Also, we're going to assume that we are still solving in degrees from 0 to 360, just like the directions above. That might change, but we're going to leave it that way for now. So the fact that the sine is equal to negative radical 3 over 2, if you're talking about the sine of theta equaling a negative, sines involve y values, and y values are only negative in quadrants 3 and 4. So that means you're going to be looking for one answer in quadrant 3 and one answer in quadrant 4. In order to get the theta by itself, you're going to take the inverse sine of both sides, which means theta is going to be equal to the inverse sine of negative radical 3 over 2, which essentially means look at your unit circle, look at your third and fourth quadrant, look for the y values, and look for the angles that have y values of negative radical 3 over 2. That would be 240 and 300. Again, one in quadrant 3 and one in quadrant 4. Then you want to go ahead and draw both of those angles. And just like always, they should have the same reference angle. So 240, if you start in standard position and you go to 240, that's going to put you approximately here. And again, your reference angle would be 60. Then if you go back to standard position and you turn through 300, that's going to put you about here. And again, you're always going to have a reference angle of 60 degrees or the same reference angle on both sides. So again, just to be clear, what is the answer to this question? 240 and 300. But again, I want you to show the angles. What were your answers to this first problem? It was 30 and 330. But again, I want you to show the angles. So you can be told, again, in a homework, on a test, on a quiz next year, to either solve it with a calculator or without a calculator. So those were both without a calculator, which implies that the answers are on the unit circle. So the question then becomes, well, what if it looks like if you're not on the unit circle? So on the next set, they're still telling you that you're going to solve between 0 and 360. Again, you would include 360, but not include 0. It says that you're going to round your answers to the nearest thousand. So that implies that you're going to need your calculator. And again, using a graphical analysis just means show the angle. If you have your calculator, you're going to want to make sure that you are still in degree mode. So if you have your calculator, you should go ahead and press the mode key. Remember, that's top leftish, and still make sure that you're in degree mode. So to solve this problem, the sine of theta equals 0.735. Again, the fact that that is a decimal that I've really never seen before is how I know that I am going to need my calculator. So from here, the fact that you have a positive signs occur in quadrant 1 and quadrant 2. In order to get the theta by itself, you're going to have to do the inverse sine of 0.375. So again, now would be a good time to take out your calculator. To do an inverse sine, you're going to do the second sine. Put the entire decimal in, 0.735. If you go ahead and hit enter, it is going to tell you that the angle in question is 47.307. And then depending on what else is going on in the problem, that may or may not be one of your answers. If you're solving an equation that's positive, it pretty much guarantees that it's one of your answers. If not, then there are some additional steps that you have to do. So remember, there should be two answers. So that's answer number 1, and I'm going to go ahead and sketch that. So 47.307 degrees. Again, you don't have to be super precise. But here would be my first angle, 47.307. And then here's the thing, there has to be a second answer. I know that that second answer has to be in quadrant 2. And I know that whatever that second angle is has to have the same reference angle of 47.307. So the question becomes then, how do I actually find what that larger angle is? Well, there's a formula for that, but it's really more of a common sense thing. If you want to find what the large green angle is, and you know that turning all the way to the horizontal would be 180, then you can simply take 180, subtract the reference angle, 47.307, and that's going to give you your answer in the second quadrant of 132.693 degrees. There should be two answers. Here's the first one, 47.307, that's your quadrant 1 answer, and then 132.693, that's your quadrant 2 answer. Gets a little bit harder for something like the cosine of theta equals negative 0.482. So then from here, I'm going to go ahead and start by identifying the quadrant. So again, we have a cosine that is negative. Cosines are negative in quadrants 2 and 3. We've been going over that for a couple of days now. How do you know where things are positive and negative? Again, all students take calculus. Cosines involve x's, which means it has to be negative on the left side of the coordinate plane. To get the theta by itself, you're going to do the inverse cosine of negative 0.482. And your calculator is going to tell you that it's 118.816. Now, we're supposed to have answers in quadrants 2 and 3. That is, in fact, a quadrant 2 angle. So 118.816 degrees. If we go ahead and give that an estimation, I would say that that's fair enough, 118.816. And then here's the thing, you have to find what that reference angle is. So to find that reference angle, remember that's the angle with the little tick mark. It's how much farther to get to the x-axis. So theta reference here would be 180 minus 118.816. That would tell me that the angle in question is 61.184. So again, all we know for sure so far is here's our first answer. Then again, the second answer has to be in the third quadrant. And I know that the answer in the third quadrant has to also start from standard position. And I know that it has to have the same reference angle. So how do I actually find that angle? Well, now I have to figure out how far past 180 did I go. So 180 plus 61.184 gives me an answer of 241.184 degrees, and that would be my second answer. So again, whatever answer comes out of the calculator If it's in the first quadrant, it is already the reference angle, and you can use it to find other values. If what comes out of the calculator is not the reference angle, then you have to find the reference angle and then find the other quadrants. So let's go ahead then and try the next one. So the cosecant of theta equals, so a cosecant, while not terrible, it's not as good as a sine. So I'm going to start by rewriting this as the sine of theta equals 1 over negative 1.235, because of course they're inverses. To go ahead and determine the quadrant, so this is a sign that is negative. Signs involve y values, and those are negative in quadrant 3 and quadrant 4. To get the theta by itself, you're going to do the inverse sine of 1 over negative 1.235, and you should put it in just like that so that you don't have to round anything. Remember, every time you do a rounding, you're technically getting farther and farther away from the answer. So negative 54.068 degrees. What does that tell us? Well, unfortunately, that is not one of the answers. Remember, you have to find your answers between 0 and 360. That would be too small. So you have to find the coterminal angle or the equivalent angle. So go ahead and start by thinking about where negative 504.068 would be. So that would put you here. But again, you're assuming that you would start, change the color for you. You're assuming that you would have started in standard position. So if you started in standard position, you have to end up approximately negative 54.068 degrees away. Remember, though, when we're talking about reference angles, we always make it positive. So draw that again, and really the reference angle is positive. So here is the first answer. In order to find that actual answer, I have to find the large green angle. So to find the large green angle, I'm going to take 360, which would have been 1 revolution, subtract off the reference angle, and that gives me my first answer, which is 305.932 degrees. Then remember that there is a second answer. The second answer has to be in quadrant 3. What I know for sure about the answer in quadrant 3 is that whatever angle I turn through, I know it has to have the same reference angle, 54.068. So how am I going to find this angle in the third quadrant? Well, I'm going to take the 180, which is the horizontal, and then I have to add 54.068. So my second answer to this question is 234.068 degrees. And again, 2 answers should always be the total. Here's number 1, and here's number 2. If you wanted to double check that you were doing this right, if you calculated the cosecant of 234.068, you should in fact get approximately negative 1.235. You might be ever so slightly off because of the rounding, but really you should be pretty close. Finally, the tangent equals negative 0.892. So starting with the fact that this is a tangent, as long as it's a sine, cosine, or tangent, the big 3, we're going to go ahead and leave it. When it comes to negative tangents, remember that tangents are negative in quadrant 2 and quadrant 4. I'm going to go ahead and take the inverse tangent of negative 0.892. That is going to tell me that my theta is equal to negative 41.733 degrees. Again, if you go back and look at these 4 examples in total, in the first one, your answer was in the first quadrant, which means not only was it an answer, but it was the reference angle. Then for the second one of your answers came out of the calculator, and then you had to find the reference angle and then work backwards. And that's kind of what we've been doing for these last ones as well. So when the equations are negative, that's when you tend to have to do more work. So if we're trying to think about what my answers are, remember negative 41.733. That's not between 0 and 360, which is how I know it's not actually one of the answers, but it helps me to find the answer. Remember that 41.733, that's the reference angle. But I did have to turn through some angle starting from standard position. So if I turned through some angle and I got 41.733, how do I figure out what that larger red angle is? Well, I'm going to go ahead and subtract from 360, 41.733. That's going to give me one answer of 318.267. Then, of course, there has to be a second answer. The second answer has to be in quadrant 2. What I know about the answer in quadrant 2 is that it has to have the same reference angle of approximately 41.733. How do I find that larger purple angle? Well, in order to find that larger angle, I'm going to take the entire horizontal 180 and subtract 41.733, which gives me my purple answer of 138.267. And again, there should be two answers, and here they are. All right, and then finally, if you're thinking to yourself, are we always going to be solving in degrees? The answer is no. So notice that for these last two problems, it tells you to find two values of theta between 0 and 2 pi. When you see 0 to 2 pi, that's how you know that you're going to be solving in radians as opposed to degrees. Because of the fact that not all of these values are going to be on the unit circle, you're going to round to 3 decimal places or the nearest thousandth of a radian as needed. You're going to show a very similar set of work and you're going to approach it the exact same way, but now your answers are going to be in radians. So a couple of different things to set you up. When they say radian mode, that means that for anything that's on the unit circle, you're going to use things like pi over 6, 5 pi over 4, etc., as opposed to saying 30 or 225. So again, on the unit circle, you're always going to use the exact values. When they're talking about decimals, you kind of have a little bit of a choice. You can either use those values that I highlighted in pink, pi over 2, pi, 3 pi over 2, and 2 pi, or you can use their decimal equivalents, which are rounded to 3 decimal places. So 1.571, that would be pi over 2. 3.141, that would be pi. 4.712 is 3 pi over 2, and 6.283 is going to be your 1 revolution. So personally, I think I'm just going to use pi and 2 pi. But again, if you're going to round, those are the values that you would be using. The second biggest thing you have to make sure you do is we now have to change our calculator and we have to go into radian mode. So if you're using your calculator, again, you're going to press the mode key, which is top leftish. You now have to choose radian mode. And just as a note for later, when you get to the homework, it goes back to degrees and then back to radians. So you have to make sure you're changing your mode as appropriate or your answers are all going to be wrong. So keeping that in mind, take a second to change your calculator back to radian mode if needed. And then let's go ahead and solve these final two problems. So the cosine of theta is equal to negative 0.9848. So because of that fact, we are going to go ahead and realize that cosines are negative. Cosines have to do with x's. So they are negative in quadrants 2 and 3. In order to solve for theta, again, you're going to do the inverse cosine of negative 0.9848. Very carefully in your calculator, again, you're going to do second cosine, negative 0.9848. That is going to give you an answer of theta equals 2.967. If you want to go ahead and sketch that, if you want to know where 2.967 radians is, you're going to want to, again, use these decimal approximations. So because of the fact that this is 1.571, and because of the fact that this is 3.141, and this is 4.712, you would know that 2.967 radians is in the second quadrant. And then again, you'd want to give it a reasonable estimation here. When you're doing so, you're going to want to find the reference angle. So the reference angle here would be how big is the difference between the closest x-axis and the angle in question. So if you wanted to find what that reference angle is, you can either do pi minus 2.967, or you can do 3.141 minus 2.967. It'll work the same either way. You might get, a slightly different answer, again, off by a tenth or so, but it really should work fine either way. If you go ahead and use the pi button, minus 2.967, you're going to get 0.175. Just as a note, if you use 3.141 minus, you're going to get 0.174. But again, for our purposes, those would be considered to be the same. So from here, that's one of our answers, 2.967 radians. Then we said that there should be answers in either quadrants quadrants 2, or that should say 3. So quadrants 2 or 3. So we now have to find the answer in quadrant 3. So remember, the second answer in quadrant 3 also has to have a reference angle of 0.175. And it has to be some angle that turned into the third quadrant. In order to find what that total angle is, you're basically going to add either 3.141 or pi plus the reference angle. Again, depending on which of those you use, you could get ever slightly different answers, but at the end of the day, it's approximately 3.317. So that would be your second answer. Remember, these are always going to have 2 answers for now. There will be times in the future where there might not always be 2 answers. There could be more or there could be less, but for now it has to be 2. And again, those are your 2 radian answers rounded to 3 decimal places, one in quadrant 2 and the other in quadrant 3. Final problem of the day. This is a cotangent situation. Remember, cotangents aren't terrible, but we certainly prefer tangents. So I'm going to rewrite this as the tangent of theta equals 1 over 5.671. This is talking about a positive tangent. And hopefully you remember that positive tangents have to occur in either quadrant 1 or quadrant 3. So I'm going to do the inverse tangent of 1 over 5.671. If I do that in my calculator, I'm going to get an answer of 0.175. 0.175 is going to be the answer in the first quadrant, so 0.175 radians. That's actually a fairly small value. So 0.175, that is my first answer in quadrant 1. Because of the fact that I was able to get the first quadrant answer from my calculation, not only is that the answer in quadrant 1, but that is actually also the reference angle. So to find the answer in quadrant 3, remember, if I go to quadrant 3, I have to have the same reference angle. So to find the answer, I'm going to take pi and I'm going to add 0.175. And if I do that, I'm going to get 3.317 radians, and that is going to be my second answer. And then again, in order to double check that these are correct, you could take the cotangent of each of those values and you should get 5.671. Again, it might be slightly off because of the rounding, but that's just a way for you to ensure whether you're doing it correctly or not. So hopefully that is enough for you to attempt the homework. The homework is half in degrees, half in radians, and then one open-ended question just to make sure you can put it all together. So thanks very much, guys, for tuning in, and we will catch you next time.